Hey folks, Phil Zito here, and in today's SBA TV episode, we are going to be going through performing takeoffs. So, my name is Phil Zito. I'm the founder and CEO of Smart Buildings Academy, and what we're going to be covering today is going to be specific to doing takeoffs. So, we're going to look at our scope review template document. We are going to look at an MEP set, and we're going to talk through kind of how do you approach this? How do you perform takeoffs? What do you do? So let's go over to the whiteboard and let's talk through this. Okay, so whenever you're approaching a new project, whether it be new construction or whether it be retrofit, you need to first go and perform what's called a takeoff. And a takeoff basically is reviewing whatever documentation you have and then reviewing that documentation and figuring out kind of what you are going to do with that documentation and what that documentation entails from a scope perspective for your projects. So what we have here is we have a scope review template document, and then underneath it we have a MEP set. So on a construction project, you're going to get all this information, right? You're going to get the MEP documents, you're going to get the specification, and from there, you're going to go through, perform a takeoff. You're going to first list out your scope, and then you're going to dive into greater detail of your scope to figure out your bill of materials for your original estimate. On a retrofit project, it's a little different because you're working off O&M manuals, if they even exist, and you're also going to be not only working off of O&M manuals, but you're also going to be walking around, looking at labels on pieces of equipment, trying to figure out what actually exists. In a future SBA TV episode, we're going to focus on retrofits and retro commissioning, but for today's episode, we're primarily going to focus on new construction. Realize that the processes learned here are still going to be the same on a retrofit project as well. Okay, so this right here is our scope matrix document, and on the scope matrix document, I'm going to just bring it over here a little bit. We have, and you can kind of see it, it's really small, but we have our takeoff process, right? Perform proper equipment count, create material list, fill out our scope matrix. So in order to perform our proper equipment account, what we're going to first do is we're going to go to what is called the equipment schedule on the mechanical drawing. And on the equipment schedule, what we're going to do is we're going to go and look kind of at the individual devices. And so what we're going to do here, let me just move this over just a little bit. And what we can see here is we've got VAV boxes. It gives us some information about the VAV boxes, gives us some notes about the VAV boxes. And we want to start then figuring out what devices we have and how we're going to approach these devices. So what you can see here is that I've got VAV boxes, right? And I've figured out from these VAV boxes that I'm supposed to provide them to the box manufacturer and get my controls factory installed. So that would be a note I would make that would affect my installation labor costs. So I would want to really kind of read through the notes, understand what's going on. And I like to start at the terminal units and work up when I'm doing scoping. And the reason why is, if you think about it, if you start at a chiller or you start at an air handler and then you work down, you are likely going to either under or oversize your control architecture. Whereas if you start with the terminal units and work up, you're likely to be more accurate on your control architecture. So by knowing how many VAV boxes I have, in this case 25, then I can make a controls architecture decision. I can say, okay, depending on what the spec says, I could potentially use a IP-enabled controller in lieu of a supervisory device and significantly reduce cost, right? Additionally, I can say, all right, I only need a single trunk instead of needing multiple trunks. And how I would figure that out, right, is I would go to the floor plan here, and I would look at my floor plan and I would start to figure out kind of how is everything laid out. I would figure out where my controllers are at so I could see my VAV boxes, right? I'm going to actually switch over here to, give me a second here. There we go. I could see that, I've got a VAV box here, got a VAV box here. I could see that I've got something else here, and I can start to figure out how I'm going to kind of run my trunk, or how I'm going to educate my electrical to run their trunk. And so by doing this, by going and first figuring out the small level of equipment, let me actually turn off sound here. I'm learning to use this every day. So what's going on here, by first doing my equipment schedule and starting with the small units and then working my way up, I'm starting to figure out labor, I'm starting to figure out material, and I'm starting to figure out scope. So from there, once I've done all this, right, once I've clarified my terminal units, then I can go up to my next level, which is going to be going back down here to the equipment schedule. One more. Let's shrink it down a little. Is my air handling unit, right? So my air handling unit, what I'm going to do with my air handling unit here is I'm going to start to figure out what that entails. So, right, because the air handling unit serves the VAV boxes. And once I figure out what the air handling unit entails, then I can go and start to do my design on that. I can start to do my scope on that. All the meanwhile, for all of this, right, we're going to be filling this out into our scope matrix. So VAV boxes, we're going to put the spec reference. I know we haven't gone over the spec. We're going to put the MEP reference, and we're going to put the quantity. We're going to do, the same for the air handlers, fan coils, exhaust fans, etc. Once I've kind of figured out what I've got from an air handler perspective, this is going to shape my valve selection, this is going to shape my damper selection, etc. Then I'm going to go and potentially check the one-line documents. This set of documents actually has really good one-lines, but that's not always the case with documents. Sometimes you will not get good one-lines, but I'm going to go through the one-line, I'm going to go through the sequence of operations, and I'm going to start to figure out, I like to start back to forward, and I like to start input to output. So I would start in the back, and I would go through all my inputs, figure out those, and then I would go through all my outputs and figure out those. And those are actually going to go on a dedicated page for the air handler unit, right? So I would go and list out my point names, my point types, the signal type, and the part numbers. I would validate this against the specification. So I would go and I would look at the specification, and I would look at the materials section, which is going to be section 2 of the spec typically for our div, and I'm going to go and look at that, and I'm going to figure out what parts are acceptable to the specification, and then I'm going to validate that against what I've selected, and that's going to build my bill of materials. Now from there, I've got a bill of materials built out, at least at a high level. I've got a scope matrix built out, at least at a high level. And now I can take this information and I can take it to my electrical and get a good estimate. I can also go and really start to dive into D through G, which is going to be identify specialized equipment. So any sort of specialized equipment that I'm dealing with that potentially poses risk. These are things like humidifiers, dehumidifiers, enthalpy wheels, heat recovery chillers, etc. Right? So you got that. And then I'm also going to go and identify any integrations. That's typically going to be called out in the spec. And so that will be my backnet chiller integrations, lighting integrations, etc. And then from there, I'm going to identify any additional labor, and I'm going to identify any specification to construction document disparities. So kind of figure out that, and that's going to be my RFI and RFC process. So through all of this, it's a relatively simple process, right? You get the documents. You got to make sure that these are, CD phase documents. You don't want to be doing this off of SDs or DDs because the design is likely to change. So you want to be working off of CDs, and those are construction documents, right? Those are right before you actually execute construction, so the likelihood of those changing isn't as high. So you do it off of CDs, you first list out your scope, you identify the MEP and spec reference. That's going to be critical when you're submitting your RFIs and RFCs, your request for information and request for clarifications later in the design process. You want to have that documented, and then you move through and create your system level, if I can click, your system level bill of materials for each system. And then once you've done that, you then put it all into a master bill of material, and you quote that master bill of material. and then you assign labor costs and you assign your subcontractor costs. That's my approach to performing takeoffs, with a little bit of estimating built into that. I should have probably divided those out, but they're kind of interrelated. So I'm going to go over and see what questions you have. Hopefully the whiteboard is a lot more clear today. We changed some lighting and things like that. The last time it wasn't as clear. So I'll see what you all have question-wise. Hey. Alrighty. So let's see what questions are coming through. Okay, nothing so far, which makes my life easy. Hopefully this is looking a little more clear. I know the resolution, for whatever reason, the resolution fades in and out. But you got the key premise here. And I'm going to actually share my screen just to kind of show y'all what I was talking about here. We're going to transition over here. And I'm going to bring this document up just for a little greater detail. Make it full size. Okay. And we're going to take so basically, as I mentioned, scope matrix, right? We list out specification, MEP reference. We list out all that stuff. From there, we translate over to the air handling unit. Actually, we'd start with the VAV boxes first, right? But then we translate to the air handling unit. Once we've done that, then we validate that against our MEP set. Just one more time to make sure that we're accurate. And we would also validate it against our sequence of operations. So if you have any questions about performing takeoffs, by all means, let me know. I will go and answer those accordingly. Thanks a ton. And let's see what comes in as far as questions. I'm going to have some coffee. It's early. Was the whiteboard more clear this time, folks? Hopefully the answer is yes. And we'll see. All right. So give you all about 20 more seconds for any questions you have related to takeoffs. This is a critical skill. So when I was first a tech, I didn't really appreciate the importance of takeoffs. It wasn't until I moved into service that I really started to appreciate the importance of takeoffs, because when you're in service, oftentimes you are going to be sitting on the bench if there's no work. And so going and actually being able to create your own work by evaluating sites and then figuring out potential solutions to that site's problems, and then being able to scope that out and estimate it, that was critical, because then I could provide these little mini retrofit projects that would keep me and my team busy for weeks at a time. And so basically I was creating our own work. So for those of you who work in service, I highly recommend you internalize this. And whenever you're at a customer site, you listen for potential problems they're having related to energy or comfort or usability of their system. And then you start to create a as-is picture of their site by performing a takeoff, maybe just a little bit at a time if they have a big site. That way, at any time, you can quickly estimate what is going on and create potential retrofit solutions that they can run through their operational budget, because retrofit solutions tend to be lower budget, and so they can tend to be fitted into a operational budget. So something, and plus you're bringing greater value to the customer. Construction projects are great for a lot of things. They are not typically great for solving existing problems at existing sites. Just the contracting structure and the value engineering aspect of construction work does not tend to lend itself well for retrofit and retro commissioning projects. So I encourage you all to take that to heart, internalize that and apply it, and hopefully that'll keep you busy in the shoulder months in between heating and cooling season. So, you know, the fall and the spring months where things tend to slow down, those were my favorite months because while everyone else was out there trying to bid schoolwork, I had already bid retrofit projects and was keeping busy doing retrofit during spring and during the fall. All right, well, that being said, hey, thanks so much for being here. We are going to be talking on Wednesday, and we are going to be talking on the topic of point-to-point checkout. So you can kind of see the board behind me over there, the controller board. It's a big mess right now, but we will be performing point-to-point checkout on that controller board and figuring out how we do point-to-point checkout. We'll also be circling back at some point and doing the hot water video that it was great audio. The video did not turn out very well, so we'll be redoing that. Thanks for everyone for being here. Hopefully you learned a thing or two, and I encourage you to share this with your fellow employees, your fellow coworkers, and just invite them to engage in this content. Thanks a ton. Take care. Oh, who has final parts? So who has final say on parts used? Okay, well, is that on a construction or a retrofit project? It depends ultimately on how the contract is structured. So the contract being structured, typically, I don't know why my video is flickering today. The contract will say kind of, hey, and you're talking about brands. Okay, well, it's typically in the spec, and it's typically a consultation between the design engineer and the owner. So the owner will go and say, I want these brands, and then the design engineer will put that into place. And it can be, hey, it's only these brands, or there can be add alternates. So there can be alternates like for like, or there can be add alternates. The difference between an alternate like for like is going to be that an alternate like for like means that it has to equal capabilities. An add alternate can be additional capabilities. So you can add an alternate. This would be like, for example, you're requiring programmable controllers, but with an add alternate, they could provide electromechanical thermostats, and maybe you accept that. So if it is owner direct, that's much easier. There's not usually a spec for owner direct work. It's usually just a scope letter. If it is contractual in nature, then it is typically the consulting engineer and the owner's rep who will take advisement from the owner and then will drive towards that advisement. So yeah, hope that helps. Let's see, what other questions? Anything else? All right. Well then, folks, I will give you back some time in your day. Hopefully this helped. Feel free to ask any questions you have in the comment section, and we'll reply, even though that will be no longer a live video. Hope to see you all Wednesday at 11 a.m. and we'll be talking about performing point-to-point takeoffs. All right, or point-to-point checkout. Thanks. Take care.